Alrighty. Well, we're a couple minutes past the hour. Other folks will trickle in as they can. But why don't we go ahead and get it kicked off for today? Um, as always, we're going to go ahead and start with the weekly updates. And thank you to Jose for taking that on this week while Ian is out on vacation. Much appreciated. You want to just quickly chime in and talk a little bit about everything that happened on the server, maybe summarize a lot of the discussion that was there. And yeah, that would be really helpful. Jose, if you're trying to talk, you might be on mute. Okay, you're off mute, but we can't quite hear you yet. Hey, Carla.
Hey.
We're still having some audio issues here. Okay. Well, if that's the case, I'll go ahead and get started by talking a little bit about everything alpha testing. I see we have 10 alpha testers thus far. So thank you to everyone who volunteered for that. As always, if you want to be an alpha tester, please make sure you've signed up at nodes.dci.com. We do give preference to people who are active in the community. Just come in and say good morning. Join into a lot of the conversations that are there. It's always appreciated. A lot of smart people in this Discord, so it's nice for the team to be able to run thoughts by y'all. Um, but yeah, so we have 10 alpha testers. I believe three of them are on the call at the moment. And just want to say thank you to all of you. The alpha testing sessions have been absolutely phenomenal. We've gotten some great feedback from every single person who took the time to do it. Um, every single person who has tried to run an alpha test has successfully been able to create a node, which I don't know how much y'all know about software development, but for that to be the case in alpha is absolutely fantastic. So we've had quite a few of them come out. We've also gotten a lot of great bug reports coming out of the alpha testers as well, both in the meetings and externally through some of the bug report pipelines. Excited to start hosting some journal clubs on things that alpha testers are passionate about. So, one of the requests for anyone who's doing alpha testing is to find a paper that they are interested in or passionate about, to annotate it and try to create a cohesive node around that paper itself. Then we'll be hosting journal clubs where they can come in, present, and do a little bit of Q&A with each individual node. It's a great way to get, people actually trying out the platform, helping to identify some of the bugs, but also helping spread the word around the platform itself. So we're excited to everyone who's volunteered to do that. Thank you all so much for agreeing to help. And if you haven't gotten your POAP yet as an alpha tester, let me know. I will make sure that that makes its way over to you. With that, Jose, do you have any better mic? Is your mic working any better? I can do the weekly update if not. I'm guessing that's a no. So I see you came off mute, but we're not really hearing anything. Okay. Well, if that's the case, I'll go ahead and do the weekly update. We've had a lot of great conversation over the course of this past week. My personal favorite has been around a lot of impact certificate funding and then some of the differences between public and common goods as a business model. So, with respect to impact certificates, I believe it was Joseph who came in and made quite a few different suggestions on the Discord for things that impact certificates could potentially include or be useful for. Things like UMA KPI options to provide impact structures for certificates. Yeah, it's okay. Discord gets a little funky sometimes, Jose. The challenges behind pricing certificates and the due diligence required for each one, and then innovation exchanges on chain. And he actually provided some links to the Innovation Hub, which is a great place for us to be able to go in and look at that. Um, I'm also very excited about the concept of prediction markets as they tie to impact certificates as a means of due diligence. But for anyone who wants to see more on that impact certificate discussion, it's in the funding channel. And additionally, the community call from last week is up on YouTube. We will be posting live YouTube updates whenever something gets added to our YouTube channel in the near future. So keep a lookout for that. Then there's also been a lot of great discussion around public and private goods coming from John Ringo about how some of the incentive structures in crypto at the moment around public goods may not necessarily be the best norm, and how projects can work to kind of change the way they're thinking about public goods to incentivize better, more community-driven development. One of the things with anything public goods is that it actually has to come from some kind of large governmental organization, or at least up until this point it has. And John, I see you actually just joined the call, so if you want to give a little bit more color on that, feel free to. But between those two things and then a couple other conversations all around the channel, been a great week. Thank you to Ian for normally doing the weekly updates and to Jose for agreeing to do it this week. Much appreciated. And with that, John, if you have anything you want to say on the public goods discussion, feel free to chime in. And if not, we'll see what Chris's Wi-Fi looks like. And if you can speak on a lot of the tech stack behind DeSci Labs, that would be awesome. But John, do you have anything to add?
I actually just missed most of that.
I was just giving a
What's the
weekly
prompt?
update on the
Okay.
rundown of the channels and some of the discussion you were having around public versus private goods and kind of the public goods model incentive structure in the general channel is one of the things that was brought up.
Yeah, in general, I just think it's I think the general gist of what I'm trying to get across is important to think about the language we're using behind everything here. Uh, if you're telling someone you're incentivizing them to be altruistic, it might be what you're doing, but they might be more hesitant than if you're just describing like how you're going to use a for-profit model to make them do things that actually benefit them and the people around them. I think that was generally it.
Yeah, it makes sense. And I completely agree. I think most folks completely agree with that. It seems like the norm in Web3 has been towards public goods and towards altruism, which is not a bad norm to set, but any norm that you set tends to take over, and pretty much everything at scale tends to break down. So I'm excited for a lot of the conversation shifting towards networked goods, public goods, and common goods working in tandem as opposed to just altruistic public goods. I think it's going to be a very healthy thing for the space to think more about business models and less about purely public goods, because a sustainable business model is more powerful than just pure altruism, in my opinion.
Yeah, and the main thing about Bitcoin, about cryptocurrency in general, is securing a public ledger, which is a public good. It's very important, but they don't like even in the white paper, if I remember correctly, the phrasing is something like we need to incentivize people to perform this task that is a public good because they're not going to do it for free. Like it costs resources to do this, so let's incentivize it. So you've built in Bitcoin built an economic model around producing a public good without ever using the phrase public good.
Which I agree, and it's powerful. And it's not bad to have people thinking about public goods, but at the same time, it does need to take into account human nature beyond a shadow of a doubt.
Yeah, definitely.
So, Joseph, I see you're on the call. If you want to quickly chime in and maybe say some stuff about conversations around the impact markets, I think that might be helpful.
Sure, certainly with pleasure. Hey everyone, Joseph here. I'm a quantitative analyst at Index Co-op with a long-standing interest in innovative funding mechanisms for science, particularly where there are market failures. And we've had a good discussion in the funding chat about ways to approach the impact certificates, which I think are extremely interesting. Part of my thinking was to, as much as possible, take advantage of infrastructure that's already available and battle tested. to minimize custom development effort and any technical risk. So one primitive that I thought might be useful are the UMA KPI options. And also forgive me if the infrastructure for the impact certificates is already built out and then this becomes moot, but I thought it might be useful to think about what some of the rails could be. So UMA, you may know, is a synthetics protocol on Ethereum mainnet, and one of their uses is for KPI, or key performance indicator options for DAOs, where essentially you have options with a strike price that exercise upon achieving some on-chain criteria or a criteria set by a manager or a multi-sig. And that way you could have a KPI option that unlocks upon achieving some predefined success criteria. So that seemed like a potentially relevant infrastructure for the impact certs. I think there are a number of DAOs using them to reward contributors from DAO treasury tokens. So that was one thought that came to mind. And then we had another discussion about how to attribute rewards across a group. And we had a pretty good, slightly tongue-in-cheek discussion about how this maps to the what's called the fair division problem in game theory. How do you divide a prize fairly among a group that have had different levels of contribution? So there's a whole literature on this in economics and game theory. But in the context of DeFi, Yearn uses this for allocating their contributor rewards with a model called Poor Comp. It's not the best name for branding, but there you go. And they've had this running for some time now, and it's cited as a working example for how they can distribute contributor rewards, in this case, methodologist rewards across a group of Yearn methodologists in a way that's fair and relatively immune to spoiling or capture. So, part of my thinking is coming from the direction to try to take advantage as much as possible of infrastructure that's already been proven and battle tested. So I thought that might be relevant as well, because it seems like there's a open question around how do you attribute, in this case, the impact certificate rewards or credit across the pool of scientific contributors. And then we had also some good side discussions about pricing the certificates, et cetera, but that gets a bit more speculative. So it was a pretty interesting, far-ranging discussion. So I enjoyed it a lot, and thanks for the opportunity to participate today.
Absolutely. Thank you for participating today. And thank you for the wonderful conversation in the funding channel for anyone who wants to go look at it. There's definitely potential to reuse existing infrastructure in Web3, if nothing else, just to get a proof of concept out for impact certificates. Seeing as in a big way, there's a lot of learning that needs to be done. So the faster we can do that, the better. I definitely love that. So I don't know if anyone else has anything that they want to chime in on with the weekly update. I'll give a quick pause for folks to do so. And if not, then I'm going to go ahead and pass it off to Chris. We'll see how his Wi-Fi works today to go over some of the tech stack behind DeSci nodes. Chris?
Hey everyone, great to be here. Testing the audio here. Can you all hear me clearly, or do I sound like a garbled robot?
Nope, you sound like a human being. Congratulations.
Good, good. I'm really happy to hear. Well, I wanted to preface this that I'm having a lot of fun with the conversations that happen here, and I'm very grateful for all the contributors that have been sharing their thoughts and also teaching me a lot of things and bringing some interesting perspectives as well that we haven't necessarily considered. So I'm really enjoying that, and I think there's a lot of wisdom that can be gathered bottom up from the type of community that we're building here. So I really encourage you, to continue contributing. We're going to keep, having some healthy discussions around all of these topics. And I've just been having a blast. So thank you for that. And with that said, I want to talk today a little bit more about the tech stack and the architecture that we're developing around DeSci nodes. And this is something that hasn't yet been essentially shared in a technical document. So we're working on different types of technical documents on that specific topic. But I thought I would give you guys a preview of essentially the background architecture and how this system works. So let's go. And by the way, I apologize in advance if this conversation could get a little bit technical or if there's some vocabulary that is not necessarily understood by everyone. So I encourage you, to just interrupt me, ask questions. I'm going to first give a superficial overview, and then depending on the questions that appear, I'm just going to dive deeper and give some more background information and see where we can take it from there. So essentially, we're developing something that we are calling right now the DeSci stack. So the idea behind the DeSci stack is that we can create a tech stack for true open access. Essentially, you could imagine right now the scientific record essentially is siloed in different databases that typically run on Amazon S3, and these databases, have different access conditions and paywalls. Some are open access, some are not. And the idea is to essentially create a system which does not rely on having silos, but rather functions in a peer-to-peer fashion. So for this, we are relying on the IPFS network and a number of other technologies that I will go into more detail. So the first idea here is that how can we create open access infrastructure which essentially is immutably open access, that we cannot, that any actor in the system can never erect a paywall of any type of sort to prevent access to the knowledge that's contained within. And how do we create a network that is mutually reinforcing, meaning that the more nodes in the network that are activated and that are contributing to the network, the safer the knowledge stored, the better the knowledge guarantees, and the greater the economies of scales that happen around it. So the DeSci tech stack essentially has three components. So there's what we call DeSci gateways. So DeSci gateway essentially provides an interface to create, access, and preserve DeSci nodes. They constitute what we could think of as the backbone of the DeSci infrastructure. So you could think of different organizations, for example, libraries, research organizations, protocols interested in public goods, running their own DeSci gateways. So what we do not want to do is be, a singular provider of a singular gateway. We want anyone to be able to run their own gateway that communicates essentially in a peer-to-peer fashion. So these gateways are designed to essentially provide a user-facing UI to create these DeSci papers, to find these DeSci papers, and to resolve these DeSci papers. The gateway serves to mirror the IPLD manifest. So for those of you who are not familiar with IPLD, it's interplanetary linked data. You could think about that as essentially an IPFS, a compliant data model that is easily traversable, that provides a unified language, a unified data model. It resembles, in a way, JSON LD. We can go back into that a bit later. So essentially, the gateway mirrors the IPLD manifest of the DeSci paper on the node on the IPFS network. And it also indexes the root hash of this IPLD manifest on the registrar. So I'm sure all of you are familiar with ENS, the ENS domain name system. The ENS domain name system relies on a so-called registrar to register and to resolve the domain name. So the DeSci nodes likewise rely on a registrar, which is a smart contract, to index and resolve the nodes. So an important function of these DeSci gateways is as a side effect of broadcasting these research objects, these DeSci nodes on the IPFS network, and indexing the root hash. They're essentially minting persistent identifiers. So persistent identifiers are a huge topic. I'm not sure how many of you have heard about that, but it's the idea of creating persistent rings that don't break. And it's a very important topic because this is an area where we can actually use decentralized technologies in a way that adds genuine value on top of Web2 technologies, because we can create persistent identifiers that do not break, that are secure, that are decentralized, and under some conditions, they're also human readable. And we're going to go back to this trifecta of decentralization, security, and human readability, which is something known as Zuko's triangle in computer science. So essentially, these DeSci gateways will secure the underlying data payloads for long-term archival by pinning the content. I want to add that there's no incentive model in this specific time for these gateways. So for now, we're considering that these are entities that are doing this out of a pro-social motive. However, it is of course something that can be considered to add an incentive layer on top of the gateways, right? So we want to, again, our development philosophy is to keep the different components that we build as modular as possible. So these DeSci gateways are essentially containerized using Docker. They're deployable in a self-hosted fashion. They can be deployed on the go. Our goal is to essentially create easily deployable kits that research organizations and libraries can operate on their servers to power their open access infrastructure in a way that is immutably open access. DeSci nodes. So we're still working on a formal definition of DeSci nodes, but essentially you can think about it as a research object, right? So a research object, this is the idea of having a singular place where you can add all of your research outputs, including your preprint, including your data, your code, maybe a video, maybe a forum post. All of these components that are essential in the process of research can be combined in one singular space. Now, these research objects are serialized using the DAG-JSON IPLD codec. So it's essentially JSON that is adapted to IPLD, and the data model. This package that is created by the DeSci gateway is stored on a decentralized repository. So this is how we define these DeSci nodes. And the third component to all of this is what we call right now a ledger of knowledge, which is essentially an Ethereum-based smart contract registrar. So registrar, again, this goes back to the ENS domain name system. The idea for this ledger of knowledge is that it's essentially storing the root hashes of the IPLD Merkle DAG. So for those of you that don't know what a Merkle DAG is, it's a very clever structure that allows for essentially very, very easily verifying that something has not been tampered with. So very efficient data structure. I mean, all of GitHub runs on Merkle DAGs. There's other repositories out there, specifically Software Heritage Foundation, that uses Merkle DAGs to archive code. And this type of data structure has not yet been applied in the context of preprint servers, in the context of generalist repositories for science and research. And this is what we're doing here, which is another innovative component of what we're building, right? And so the idea of this ledger of knowledge, this registrar, is that it's essentially indexing these root nodes, and it's securing versioning access rights via SBT, soulbound tokens, that are linked to the creator of the node's wallets. So this ledger essentially allows us to create version invariant, human-readable, secure, and decentralized persistent identifier for each research object. So while it is not yet decided whether or not it is an advantage to create human-readable persistent identifiers, it is something that is possible just in the same way that DNS domain names fulfills these three properties. So essentially that ledger, you could ask, well, why? why should we index all of this on a smart contract? Why can't we just, keep it in our silo and essentially have that, on a centralized database? And I think the response to that is that, well, that really makes it universally accessible, because the Ethereum blockchain is a universally accessible database. Anyone who's subscribing to the event logs of that particular registrar or querying the DeSci subgraph, so that's another topic that goes back to the graph and decentralized indexing, essentially can retrieve the entirety of the data that's stored. By retrieving the root of that Merkle DAG, you can then retrieve all the rest on the IPFS network. So what are the technologies that are underlying these three components, which we call the DeSci stack? Well, there's essentially IPFS. I mean, I'm sure all of you are familiar with IPFS at this stage. It's a peer-to-peer hypermedia protocol for content addressing. Something that's quite fantastic with IPFS is that it's there's many really, really interesting points about IPFS. One of them is that it allows us to create secure and decentralized identifiers for all components of a research object. That means whatever you add, be it a video, an annotation, a paper, anything, you can have an identifier which is essentially a one-to-one mapping with the underlying object that cannot be tampered with, meaning that it is not susceptible to things like content drift, right? There's nobody that can, the content cannot be changed without changing the hash. So IPFS offers improved security, better content integrity. It's a really, really interesting core technology to our stack. Then there's IPLD, which is a data model to essentially link components in a consistent way that allows for a data structure to be universally traversable regardless of the protocol. And essentially, an interesting thing about IPLD, and I think a simple way to think about it, specifically about the JSON IPLD, is think of JSON, except you have URIs that are encoding the content of the objects that they're linking to. Right? That's a simple way to think about IPLD. Then there's Filecoin. So the idea with Filecoin is that we also need a backup system on top of the gateways. So the one of the challenges with IPFS is that while it does guarantee that the content identifiers are permanent, essentially their underlying payloads are not. So you need to pin the different content. You need to pin the data, the payloads of those contents. And so the idea is that we need to create a system which essentially allows us to have redundancy when it comes to storage, so that we can really be certain that we can secure information for the long run. And Filecoin is very interesting because it's actually much cheaper than other solutions that are currently used to preserve the scientific record, like Amazon Glacier or Storj. Ethereum, at this stage, I think that has been made clear with the registrar contract. And importantly, we're also using Optimism, right? So Optimism is a L2 scaling solution based on optimistic rollups, which offer us just the type of security that we need for a particular purpose. The thing that's very interesting about Optimism is that now we can actually make that system scalable, in the sense that it would only cost about $1 to $2 to commit a DeSci node to the registrar, which is something that is eminently feasible from a cost point of view. Now, all of this hasn't, this architecture we built has not appeared out of nowhere. So there is a number of prior arts on that particular topic. I'll link these articles, these scientific articles that have come out quite recently in computer science about creating fully decentralized architectures for repositories. And maybe next week, we can discuss some of the core differences between how this prior art has been conceptualizing these decentralized repositories and the approach that we are taking in our architecture. One point that I think is poetic and interesting to bring up is that there's something known as Zuko's triangle. So Zuko's triangle is a question of how good is your naming system? And there's three different properties of Zuko's triangle. There's the idea that Is your naming system secure? Is your naming system decentralized? Is your naming system human readable? And the idea of Zuko's triangle, which is like you can only choose 2 out of these 3 properties. And very interestingly, solving Zuko's triangle goes back to Aaron Schwartz. So Aaron Schwartz is this open access freedom of information martyr who was unjustly and harshly sentenced for downloading data sets from his university, not data sets, journals, articles from his university. Was a brilliant internet pioneer, and he wrote a solution to Zuko's triangle on his blog by essentially relying on blockchain technology to satisfy the 3 properties. And to the best of my knowledge, it's essentially this solution that was first proposed on his blog, which led to innovations such as Namecoin, which later on essentially became other projects used the same structure, such as the ENS domain name system, and became hyper successful. And it's essentially the ENS domain name system solves Zuko's triangle by providing 3 different properties. Right. So yeah, so we are standing on the shoulders of Giant, and I will be posting some of these research papers, and I'm really, really curious for the type of conversations that can come about it. So now I will go to the question in the stage chat.
All right. If anyone has a question, feel free to just chime in. I'm sure there are a couple other folks who will be posting on here. Also, I know we've been throwing files and concepts at you for the past 30 minutes. Been doing my best to keep up and continue posting things on the chat. So hopefully there are enough resources to keep folks busy for the next week there. I see we have A. Flores and Semi Crypto, who are both typing out questions at the moment. One question that I have for you, Chris. If someone wants to host a gateway, what kind of hardware and infrastructure would you expect them to have? Is it something where anyone could host a gateway, or is it more specialized software or specialized hardware?
So in principle, anyone can host a gateway, just like anyone can host a local IPFS node. Now, whether or not that's a desirable thing to do is a completely different question. I think there's a very good argument to be made that a gateway should have a 99% availability, meaning that you probably want to have some server architecture either in the cloud or self-hosted servers. But essentially, there's no requirements beyond quite basic things, right? So you need the ability to run a basic IPFS node, and you will have also the need to be able to respond to the load on your server, right? So typically, if you have just a few people, posting, creating, committing DeSci nodes on chain, that will be all fine. But let's say if you have thousands and thousands of people that are interacting with the system, then you're going to need to scale up your specific technical needs using typical technologies, Kubernetes, cloud, all of this, right? So that's the idea. So anyone can host it. Whether or not it's desirable, it's probably not. You probably want to have, especially if you're expecting a lot of traffic, you probably want to have specialized infrastructure for that.
Okay, thank you. I saw where A. Flores and Semi Crypto were typing out questions in chat. In the meantime, does anyone else have one they'd like to ask?
And I can add a few things. So the DeSci nodes, essentially, they create 2 types of persistent identifiers. And perhaps before I talk more about that, I want to just talk about the current state of persistent identifiers in science, which is something I'm sure most of you don't know about. And apologies if this topic is putting most of you to sleep, because I understand it's not the sexiest part of it, but it's a very fundamental part when it comes to archival systems and ways to preserve knowledge. So the scientific record right now largely relies on the digital object identifier, DOI. And that's our persistent identifier of choice. It has been devised by the CRNS at the behest of the American Association of Publishers and introduced in the year 2000. It was a wide success. It has been adopted essentially by quite universally at this stage by now. And it's essentially been adopted as a result of a need to protect and reinforce copyright protection in the digital age. So I think it started in the mid-90s, where the American Association of Publishers wanted a way to better track who owns what and who has the right to sell which content. And for this, they mandated the CRNS to create this system. And essentially, it's based on the handle system. I'm not going to go too deep into it, but what you can think about it, in a very simple way as a lookup table, right? So it's a way where you link a resource on a publisher website to a specific digital object identifier in the way that the digital object identifier will resolve to that publisher's website. So you can test that. So you can go on a scholarly preprint platform, pick a DOI, or on a publisher website, pick a DOI. You can add DOI.org as its prefix if it's not there yet, and you can see that it will resolve and it will redirect the URI to the place where the digital resource is hosted. Now, there's a lot of problems with DOIs. First thing is they need to be crawled constantly, right? So Crossref, one of the DOI providers, essentially has to crawl these persistent identifiers all the time, because every time a publisher makes a change to their database model, migrates to their database, or essentially these things break. And they break because they're lookup tables. So every time you change or migrate your database solution systems, you are prone to human error. That's why Crossref has to send them notifications. Hey, this is the list of DOI that broke. Please fix them ASAP. And of course, all of this is very inefficient from a resource point of view. DOIs are also inconsistent, and persistent may not be warranted at all. So they're inconsistent in the way they resolve, meaning that, and I think a lot of DeSci node beta testers have tried, to essentially add a manuscript or preprint using a DOI. It works sometime, but essentially it's very inconsistent, because any publisher or silo that hosts a piece of the scientific record can decide on how they want to resolve a DOI, and that's a problem. So it's not something which is resolvable as in a universal way. And there's excellent research on that has been done. I'll also link to that. DOIs do not protect the resource they index against content drift. Right, so I'm a publisher, and I think there was a case recently of this where there was an image manipulation in a bioscience publication. And essentially, the publisher just swept it under the rug, quickly fixed it, told nobody about it, and now the digital resource that has been indexed by the DOI has changed in a stealthy way, meaning that there's no digital trace of that change, and that's a case of essentially information manipulation. But there's also cases of content drift which are much more benign, where essentially the resource changes. And content drift is a pernicious problem, because it's not like your crawler can alert you to content drift unless you've kept a version of the previously indexed resource, which is not what crawlers typically do. So you have essentially no guarantees that the underlying content will be returned as its original version. Also, DOIs cost money to mint, right? So they cost about $1 plus a subscription fee, sometimes more, depending on the intermediary registration agencies which interacts with the lookup table on DOI.org and issues a DOI. Typically, it amounts to about $1 a piece and a subscription fee, though. So that's what typically Crossref would charge for a DOI. So we can go quite deep into that topic. Right? There's a number of properties beyond the three that I cited previously. So decentralization, security, human readability. We can decompose some of those. There's a list that actually has been really, really well presented by the Software Heritage Foundation, which talks about important properties of quality persistent identifiers, right? So if you're interested in that, I'm happy to go into detail. There's also going to be a technical paper with the specification and a Git book that we will be publishing with our next big batch of updates to the DeSci node system.
Yeah, so Chris, we do have two questions on the chat real quick, if we can go into those. And I actually would love to hear a lot more about a lot of these, a lot of persistent identifiers and the problems with current DOI systems. But the first question, is the storage for DeSci nodes decentralized, and does it use IPFS or Filecoin? Can you go a little bit further into that?
Yeah, sure. So just one thing, I'm a bit confused. Where are the questions pouring in, by the way? Which challenge? Is it on stage chat? Because I do not see this question there.
Yeah, so their Discord has recently added a new feature that is chat on an actual voice channel. It is the open chat. If you go to the community call channel, there should be a little icon that says open chat. That's where they're coming in on. I think we may continue to use the stage chat in the future, though. 'Cause it
Oh,
seems
I
to be a
see
little
it.
bit more
Thank you.
difficult to
Okay,
find.
I had no idea. Oh, wonderful. Wonderful. Thank you. Oh, great, great. I see it. Okay. Oh, I'm happy people are finding it interesting. Okay, is the storage decentralized? Yes, it uses IP. So IPFS and Filecoin are not the same thing, but they're closely related, right? So you can have essentially you can archive data on IPFS using Filecoin. So Filecoin is an incentive structure on top of IPFS, but not restricted to IPFS necessarily. So all the data is on IPFS, on the nodes, on the IPFS nodes that are run by the gateways. In addition to this, we're now looking to create an automatic backup system through the DeSci Foundation or some other entity or something we could do with the DeSci gateway. So this is music for the future, probably for next year. But the idea is that we want to have both a system in which gateways pin the content plus a redundant system in case there's essentially global failure of the gateway to pin a specific piece of the content, and that would be handled with IPFS. With Filecoin, which is extremely cost effective for that specific purpose. So yes, you can actually think of the storage as fully decentralized.
Okay. And then the next question, you briefly mentioned soulbound tokens. Are they going to be a part of the system, and what will their role be?
Yes, so not talking about reputation yet. Essentially, we're using non-transferable tokens. So you could call them soulbound tokens according to the recent developments around that. But essentially, non-transferable tokens that allow authors to gate versioning rights to their work. So that means you're essentially using a non-transferable NFT in a way that allows you to interact with the registrar, where you have minted your persistent identifier, where you have minted that node, and which allows you to update the metadata associated with that node, which is that the root hash of that Merkle DAG. So in a way, it is there to do two things, right? So it serves a technical purpose, meaning that only the authors of a specific paper can change the content of that paper and can make new versions. And the second purpose it serves is a way that we can track who contributed what using their Web3 wallet, which is essentially a primitive for a future DeSci-based reputation system. So I hope that answered your question. I'm happy to go more into details if you want.
It seems like it does. So one question that I've gotten quite a bit from different folks, obviously DeSci nodes and a lot of the tech behind it is going to be open source. What point do you see other projects interfacing with this larger infrastructure? And how do you see it being used by the DeSci space as a whole?
Yeah. So it's going to be open source. I think I would love to see different decentralized communities using that infrastructure to essentially typically have their sponsored scientists or people that they fund or people that are interested in doing research to essentially give them a gateway to the DeSci ecosystem. Right? So I can imagine, Web3 protocols, like protocol labs, like Chainlink, maybe the Graph, using, creating, popping up their own gateway for their own researchers, for their own research communities. You could also imagine BetaDAO for longevity, and others, could essentially be creating their own DeSci gateway that would all interact on the same registrar. So that's the idea behind it, is that, and if we want to go back to the spirit of decentralization, the thing is, you cannot create it's very the decentralized technologies nowadays are absolutely not ready to replace cloud-based computing. Right, we're very, very, very far from that. But now, it doesn't mean that cloud-based computing cannot be decentralized, right? Because the idea of a gateway is that even if they are deployed on the cloud, you can have multiple different actors and participants deploy their own gateways, and which essentially creates that form of decentralization, which is also important for moderation, right? Because I think moderation is a big topic, and it's also a big can of worms. You don't want to essentially have, a central party that is deciding, Ministry of Truth, what is legit, what is not, what should be, taken down, what should be kept up. I think it's much better if moderation happens at the gateway level or at the so-called community level, right? So different communities can have different moderation policies, and they can essentially pin or unpin data from the UI from their particular gateway. So that's a way to do it. A scientist, essentially, by going into any gateway, any DeSci gateway can pick can pick their choice of gateway, and these gateways would have a whitelist of people that they essentially pay the cost for, which is $1 to $2 again, for posting a research object. And the idea is we don't want to have that cost put on scientists, because it creates a tremendous UX friction, essentially, right? Which is very, very bad for adoption. So one of the big principles here is that despite all of this, future tech that we're trying to implement for these fully decentralized repositories, really, really, really thinking very hard about user experience and how to make it feel like a Web 2 experience while having a Web 3 backend that provides strong guarantees for open access and all of these things, right? So that's the idea.
So another question that I've had, having worked with cloud computing a good bit in the past, I know a typical cloud computing model doesn't cost a ton to put information in, but can regularly cost money to pull information out. It's very difficult to transfer off of cloud computing servers. Do you know if IPFS suffers from this issue as well?
So yeah, so again, so these are two different things. So the retrieval of information is what costs money. Basically, when you want to serve a lot of different customers or a lot of different people, your cloud bill can increase, right? So typically people use Amazon, or there's other number of providers out there. And as I said, there are costs associated with running these gateways. There's cost of storage on IPFS, so that means pinning the information. There's cost associated with traffic. There's costs associated with maintenance and deployment. So all of these are costs. We haven't yet, but we can think about the opportunity, again, of creating a modular system in which you have a base layer, and you have an incentive layer that goes on top of it. Now, my gut feeling is that we probably do not need an incentive layer for these gateways, because these research organizations will be more than happy to sponsor and help preserve the scientific record. But it could be that there's some very interesting models to explore as well, to create even more uptake and creating incentives for others to deploy and to onboard a lot of the scientific record. So I think these are all quite exciting opportunities. Again, there's so much to build. We haven't yet really put a lot of thoughts into creating incentive structures on top of it, or whether even it is necessary, but it is a possibility.
Awesome, thank you. I think I've asked the last 3 questions in a row, so I don't know if anyone else has anything that they want to ask around all this. I know it's a lot of information, so If not, that's okay. I see Ellie is typing something into the chat right now. Um, in the meantime, I did have one other quick question for you, Chris. Are there any expected sizes for nodes, any size limits that you think will likely be put on this? And how does the system deal with a lot of private data, things that can't necessarily be open?
Yeah, great question. So one of the so there's a pernicious problems in science right now is that people are encouraged to post their data, but then the easy way out is like, oh, this is private data, and then you're essentially you're off the hook. This is a big problem, and specifically that what people should be doing is post so-called restrained data access notices, which is a type of component that will be supported by DeSci nodes, which is essentially first of all, it tells your readers, where can that data be accessed, under which conditions, where's the portal, who are the people that can access it. It's essentially a way to preserve a trace of the access conditions for restrained access data sets, like typically data sets like genetic data or private data. Human data has typically quite some tough restrictions around it. It has to be GDPR compliant. It has all sorts of red tape, and that is not something that we see ourselves storing. I know there's protocols out there like Ocean protocols and others that are trying to create solutions around accessing restrained access data in a way that is on a crypto protocol. I am not personally convinced about these type of things for the very simple reason that what prevents data from being copied unlawfully is essentially the threat of a lawsuit, and that's the only way, because data is slippery, right? There's even if you tell me that this is private cloud, you cannot download the data on your computer. Well, who gives you a guarantee that I'm not taking a screenshot or crawling my screen or using some other devices to take the data out? You cannot, right? It's impossible to prove that data has not been copied, and that's why data is slippery. So we do not want to be at this stage, at least, entering that type of design space. But what we definitely are really, really interested in is creating a standard component to essentially register the access conditions for restrained access data. There was another part to your question, Eric.
That's a fantastic answer, and thank you. So Ellie just posted a question in chat, and I think this will be the last one for the community call. What are your thoughts on how your protocol will allow different sized research entities, or ARCs, to exist without potentially leading back into the issue in our current journal system, where researchers need to cater their research to more dominant journals because of the job security and access to future funding that it can provide? If we had a big ARC that had more methods for funding researchers, how do you balance that potential power?
Well, at the end, so there's, I think this is, first of all, that's an incredibly complicated question. There's lots of ramifications to this question. I would say that the way we see major issue in science is that reproducibility and replicability are essentially becoming decoupled from impact, or have been decoupled now for a couple of decades. This is why great researchers and scientists like John Ioannidis, have published papers saying why most published findings are false, and that's a really big issue. So let's say, let's put it this way: if glamorous journals today, if the current system, would essentially had a tighter coupling between the prestige of the science of different research objects and reproducibility and replicability of said research objects, I think a lot of the current problems would be addressed. Now, that doesn't mean there's not tremendous issues around funding, right? Which you could think about as a correlated but not, one-to-one mapped problem on the journal question, right? So if essentially we could have a system which recouples reproducibility and replicability with impact, while at the same time creating more transparency and returning the value of scientific curation to scientific societies. Meaning, you go to, let's take a very reasonably priced journal like PLOS. PLOS is a mega journal. They charge about $2,000 for publishing your research in open access. Of course, researchers, in the process, they see they don't see a single penny out of that money. Right, all goes into the journal ops. Now, if we could have a system that would return that value, or let's say 2/3 or 3/4 of that value to researchers, I think we would already be on a tremendously transformative journey in creating and accelerating the pace of knowledge production and creating a more replicable and more robust knowledge. So I think that's really our goal here, is to return the value of curation to scientists and to recouple replicability and reproducibility and alternative metrics that go beyond the tyranny of the impact factor. So those are really the North Stars that are guiding us. Now, in terms of arcs, right? What if there's a big arc to rule them all? I don't think that's going to happen. I think, first of all, anyone can create an arc. What the DeSci Foundation will do is they will be providing essentially an SBT to arcs to say these are arcs that we essentially we support. We'll give them startup funds. We believe in them, so it's essentially a quality label. But we're not using that as a way to gate the creation of arcs, right? So you could have all sorts of arcs that could form and pop up, and within that collection of arcs, you'd have some of them, maybe most of them, that would have that SBTs that says, well, these arcs have been supported, financially and on a different level by the foundation. So that's how we're thinking about it right now.
So Ellie, hopefully that answers the question. And with that, we are at 12:59. So I think that's pretty much it for today's community call. As always, it will get posted on YouTube. We will start having YouTube posts notifying folks whenever it actually does get posted. Thank you to everyone for joining. Thank you for all of the incredible contributions and conversation throughout the Discord. Thank you, Chris, as always, for speaking for an hour straight on the community call. It's amazing to hear everything that's happening, and I think we all have a lot of learning to do from everything that you just talked about. And with that, I think we're pretty much done for today.
Thank you, Eric. Thank you, everyone, for joining.